Hi everyone, welcome to part 2 of this tutorial covering problems involving pulleys. So in the last tutorial, in part 1, we looked at problems involving pulleys where both objects were hanging freely. In this tutorial, we'll be looking at 2 examples where one object is hanging freely and it will be connected by a light inextensible string to another object which will be resting on a horizontal surface. So let's get started. So problem number 3, we've got an object which is resting on a horizontal surface of mass 12 kilograms, and we've got another object which is hanging freely which has a mass of 18 kilograms. These two objects are connected together by a light inextensible string which is passing over a smooth fixed pulley. The objective of this question is to calculate the magnitude of the acceleration and also the tension in the string. So once these objects are released from rest, they will be in motion, and if they will be in motion, we will need to use Newton's second law. So before we do that, let's go ahead and start labeling the diagram. So let's start indicating all the forces. So let's focus on particle A. So particle A will have a weight acting downwards of magnitude 12 g newtons. It's resting on a horizontal surface, so since it's in contact with this surface, there will be a contact force, a normal reaction force acting vertically upwards. It's connected together by a light inextensible string, and the string is taut, so therefore there will be tension in the string, and we can indicate the tension as follows. And if we now focus on the next particle, the 18 kilogram particle, this object will have a weight acting vertically downwards of magnitude 18 g newtons. Now in this particular problem, we're going to assume that the horizontal surface is going to be smooth, so that when the object is moving, there will be no resistance force. So on this particular diagram, we've indicated all the forces. There's only one thing missing that we need to also include, and that's going to be the direction of motion. So once these particles are released from rest, the 12 kilogram particle, particle A, it will accelerate towards the right. I will indicate that with an arrow. And particle B will accelerate downwards. And we can indicate that as such. Now both of these two objects are moving in different directions. If they're moving in different directions, we will have to set up an equation of motion for each particle separately. So let's start off with particle A. So particle A has a mass of 12 kilograms, so we'll just indicate it. So if we're going to apply F equals ma, well, it's moving towards the right, and we've got tension also moving towards the right, and we're going to remove any resistance forces. Well, in this case there are no resistance forces acting on particle A, so the resultant force acting in the direction of motion, which is horizontally, is given by T newtons, and this will be equal to the mass of particle A, which is 12 kilograms, multiplied by the acceleration given by A. So this would be labelled as equation number 1. Now if we move on to particle B and now apply F equals ma, well, this particle is moving downwards, and here we've got 18g also acting in the downward sense, and we've got tension acting in the opposite sense. So the resultant force acting on particle B would be given by 18g minus T, and that's going to be equal to the mass of particle B, which is 18 multiplied by the acceleration a, and that's going to be now labelled as equation number 2. So we've got two equations with two unknowns. We're now ready to solve them so that we can determine the magnitude of a and the magnitude of t. So in a similar format to what we've covered previously, we're going to add these two equations together. And when we add these two equations together, the t and the minus t would cancel. So we're left with 18g. And that's going to be equal to 30a. And using your calculator, we can calculate the magnitude of the acceleration, which works out to be 5.88 meters per second squared. So, now that we've calculated the magnitude of the acceleration, we're now ready to also calculate tension. So, to calculate tension, we can go back, and it'd be a good idea to use equation number 1. Equation number 1 says T is equal to, so tension is equal to 12 multiplied by the acceleration, or we've just determined the acceleration to be 5.88, so we can calculate this and you should obtain 70.56, which would be 70.6 newtons to 3 significant figures. So, this was problem number 3, a very, very simple problem considering we had no resistance forces. Now in problem number 2, we've got a very similar scenario. So again, we've got two objects connected together, particle A and particle B, connected together by a light inextensible string passing over a smooth fixed pulley. Now in this scenario, we're also told that particle B is hanging 0.5 meters above the ground, and we're also going to say that the horizontal surface which particle A is currently resting on is going to be a rough surface. So if the surface is now going to be rough, as particle A is going to move, it is going to experience some form of resistance force. Now in this particular problem, we're going to say, well, the resistance force acting on particle A is going to be a constant 25 newtons. So we'll indicate that on the diagram. We can also now include all the other forces acting on the diagram. So we've got tension in the string. We've got the weight on particle B acting downwards of 18g newtons. Now it's optional if, like in the previous question, we didn't need to use any of the vertical forces acting on particle A. So it's optional. If you wish to include them, we can include them. So we've got a weight force of 12g newtons acting downwards, and we've got a contact force of r newtons acting vertically upwards. Now the particles are going to be in motion once they're released from rest, and as before, particle A will accelerate towards the right and particle B will accelerate downwards. Now the objective of this question is going to be to determine what the acceleration of the system is going to be, but then also try to determine what the maximum distance particle A will cover, assuming it doesn't reach the pulley. So let's start off by writing down our equations of motion for each of these particles. So for particle A is going to be in motion. It's going to be moving towards the right. So moving towards the right, we've got tension moving towards the right, and we've got a constant resistance force of 25 newtons acting in the opposite direction. So therefore the resultant force acting on particle A would be given by T minus 25. And that's going to be equal to the mass of particle A, which is 12, multiplied by the acceleration A. Moving on to particle B. Now particle B is going to be moving downwards. Well, moving downwards also we've got a force acting downwards, which is 18G, and we've got a tension force acting in the opposite direction. So therefore the resultant force on particle B would be given by 18G minus T. And that will be equal to the mass of particle B, which is 18, multiplied by the acceleration A. So we've got two equations once again, which we're going to label number 1 and number 2, and we're going to solve these equations by adding. Once again, adding works easier since we've got a positive t and a negative t coefficient. So by adding these two equations, we end up with 18G minus 25 is equal to 30A. And solving for A, you should end up with an A value of 5.05 meters per second squared. And as such, we can also use any one of these two equations to also calculate the tension. And if you wanted to calculate the tension, you can verify that tension would be given by 85.56 newtons. So these are two key results that we have obtained in this current problem. Now, the goal now of this particular question is to determine what the distance particle A will cover, assuming it does not reach the pulley. In order for us to do that, we're going to draw ourselves a little diagram. So here's our horizontal surface. Here's particle A currently sitting at rest. So it's currently at rest. As particle B descends and covers 0.5 meters, it strikes the ground. Particle A had also covered 0.5 meters. So now particle A is now sitting in this position where it's covered 0.5 meters. However, since particle A was in motion, it will continue to move towards the right until it comes to rest. So, in order for us to calculate the total distance travelled by particle A, we also need to work out what this additional distance that particle A had travelled after particle B had hit the floor. So, how do we do that? In order for us to calculate this additional distance, we need to know what the velocity of the particle A is going to be at this particular point. And we can calculate that simply by calculating the speed of impact of particle B as it hits the floor. So let's start off with that. So if we now focus on particle B again, so what information do we know about particle B? Well, we know it was initially at rest. We know it began to accelerate at 5.05 meters per second squared. We know it covered a distance of 0.5 meters, and we're trying to determine the speed that it hits the floor, in other words, the speed of impact. So we can calculate that using our constant acceleration formulae, v squared is equal to u squared plus 2as. So we end up with a speed of impact value of 2.247 meters per second. So particle B has struck the ground at 2.24 meters per second when it descended 0.5 meters. Particle A moved across 0.5 meters, and at that point it has a velocity of 2.247 meters per second. Now, particle A will continue to move forward since at this stage the string has no more tension. The string has now become slack. So particle A will continue to move forward until it comes to rest. So therefore the particle is decelerating. So what we need to do is we need to calculate what that deceleration is going to be. So let's draw ourselves another little diagram. So we've got our particle A, which is connected by a string which is at this stage slack. So in other words, there's no tension in the string at the minute. However, remember, there is still a constant resistance force of 25 newtons, and it's still moving towards the right. What we want to do is we want to work out what that deceleration is going to be. So to calculate that deceleration, we can use Newton's second law, and we can say, well, the resultant force F will now be given by minus 25 newtons. Now remember, there is no force going towards the right since there's no more tension in the string, so that's 0 newtons, and we've got a constant resistance force of 25 newtons, so the overall resultant force acting towards the right would be minus 25 newtons, and that's going to be equal to the mass of particle A multiplied by the acceleration. So we can now calculate this value for our acceleration, and you should obtain minus 2.08 meters per second squared. So particle A is now going to start decelerating until it comes to rest. So we can use this information to help us work out what this distance is. So let's record everything that we know. So we know for particle A, we've got u is equal to 2.247. Now remember, that was the speed as soon as the string became slack. It will begin to decelerate at minus 2.08 meters per second squared. It will arrive at a velocity of 0 meters per second, and we wish to work out the distance that that particle is going to travel. So we can now use another formula. V squared is equal to u squared plus 2as, and we can substitute everything straight in. So what is the overall distance travelled by particle A? So we're going to go back to this diagram over here. So particle A travelled 0.5 meters. At this point, particle B has hit the floor. Particle A will continue to move towards the right, but slow down until it comes to rest, and it's now covered a distance of 1.21 meters. So what's the overall distance? Well, the overall distance is basically going to be 0.5 meters plus 1.21 meters, which works out to be 1.71 meters. So the overall distance travelled by particle A would be 1.71 meters. So I hope you found both of these two problems extremely useful, and hope you've got a better understanding in tackling these types of questions. I hope to see you in the next tutorial.